here's our last example, a two-solution case for side-side angle. We're going to find two triangles for which A is 12, B is 31, and A is 20.50 degrees. So we're going to use the H equals sine of A just to kind of check things out a little bit. We want to know if A is between H and B. So if you remember, we talked about this a little bit earlier. We know that there's supposed to be two, and maybe what doesn't tell you that there's two, it just says to solve. So if you find this case where A is between H and B, then you know there are two different answers. So let's test that out. Let's see if A is between H and B. So we know that H equals B sine of A, so H equals B, so 31 sine of A, which is 20.50 degrees. And if I plugged it in the calculator, that's 10.86 meters. So the height is approximately 10.86 meters. A is 12 meters and B is 31 meters. So that's definitely true. So we know that we have a two-solution case. We have two triangles, even though it tells us already, this is how you would tell. So knowing this information, we want to use, finding the angle B, right? We know A, B, and then angle A, so we want to find angle B. So let's use sine of B over B equals sine of A over A. So sine of B equals B times sine of A over A. And so we know B is 31, then sine of 20.50 degrees over A, which is 12. So that is sine of B. And so you find that sine of B, after plugging it in your calculator, is approximately 0.9047. Then you do the sine inverse in order to find the angle B. So B1 is 64.78 degrees. Okay, then we need to find when it is the second case. So in order to find that, because we already know that there's two angles, so one way that I think about that, and maybe you could as well, is how did we find that other angle? So if we know that it's 64.78 degrees, how did we find this other point here? So this is pi. So remember, pi is also 180 degrees. So one way to think about that, to find the other one, so B2, is we take 180 degrees minus 64.78 degrees. So therefore, the second B is 152.22 degrees. So that's our obtuse angle, right? So we have an acute, and then we have an obtuse angle B. So now that we know that, now we're going to solve for both triangles. So what are we missing for both? Well, we need C, angle C, and then we also need the little c, so C1. So in order to find the angle C, we're just going to take 180 degrees minus 64.78 degrees minus 20.50 degrees. And so we find in that case that C is C1 is 94.72 degrees. Okay, 94.72 degrees. So that is C. Then we need to find the side C. So let's use C over sine of C equals A over sine of A. So C equals sine of C times A over sine of A, and this is C1. And then, so we know that sine of 94.72 degrees times A, so A is all the way at the top, A is 12 over sine of 20.50 degrees. So that gets us side C. C, therefore, is approximately 34.15 meters. Okay, so we figured out C1. So let's do B2. So to find C2, we're going to take 180 degrees minus 115.20 22 degrees minus 20.50 degrees, and we find that that equals 44.28 degrees. So that is our C2. So then using the same ratio, C over sine C equals A over sine of A. So C equals sine of 44.28 degrees times 12 over sine of 20.50 degrees. You would find that C is 23.92 meters. So go ahead and try this example here. Find two triangles for which A is 4.5 feet and B is 5 feet and A is 58 degrees. So it already tells you that there's two triangles, so you don't have to do that test where you're trying to figure out if A is between H and B, but in the homework you will have to, so try this out. If you tried this out, you would have gotten B1 would be 70.44 degrees, and I did check it out. So I did find that the height is about 4.24, which is less than A of 4.5, which is less than B of 5 feet. So then I figured out angle B, so I did sine of B over B equals sine of A over A, and I found that sine of B equals 0.9423, or angle B is 7.44 degrees. Now because I know that there are two angles that B could be, then I take 180 degrees minus that 70.44 degrees that I found, and so we find that B2 could also be 109.56 degrees, so that's the other triangle. So this is the acute and this is the obtuse. So then you solve for C for both. So angle C is 51.56 degrees, and then the side is 4.16 feet. And then for the second one, C2, that is 12.44 degrees, and then you find that the side is 1.14 feet. So just a quick thing on the homework as well is that you will find things, because we haven't really talked about degrees and minutes. So number 12 in the homework has A is 5 degrees and 40 minutes, B is 8 degrees and 15 minutes, and B is 4.8. And so you're supposed to find what you are missing. So we need to find C, we need to find lowercase a, side A, and then side C as well. Now the thing that you probably don't know is how do we convert these to degrees, or you can just solve it as is. So in the book, it might ask you on WebAssign that you actually have to do it in minutes. The answer is in minutes. Now, how this is, so just thinking about how many minutes are in an hour, and there's 60. So one way to think about this is you could convert it to decimals, and to convert it to decimals, it's really 40 over 60. So if you do that, you would find that A is approximately 5.67 degrees. Then for B, that's 15 over 60. So you would find that B is approximately 8.25 degrees. Now again, depending on whether or not they want it in minutes, and it possibly might. So if I want to find C, I take 180 degrees minus 5 degrees, and I'm going to do 40 over 60 minus 8 degrees, and then 15 over 60, and then I subtract. So what I'm going to do is I'm going to change this 180 to 179 degrees, and 60 over 60 minus 5 degrees of 40 over 60, and then minus 8 degrees of 15 over 60. And so what you would find is that that ends up being 166 degrees, and you're left with 5 out of 60, or that is 166 degrees and 5 minutes. Okay, so just in case it's going to ask for that. Then the last thing that you need to do, 160 degrees and 5 minutes, is to solve for the rest. Now in the calculator, there is a button where you could type it in. Now in my calculator, it's next to the delete button. So if you, in my class, the TI-30X2S, you'll see DRG, PRB, the button that's next to the arrows. Then you see DEL. Underneath the DEL, there is this degree, minute, and then this is actually seconds. So you'll find that when you type something in, so if you type in, for example, 166, you press that degree button, then you select the degree, then you type in the minute, 5, and then you press that button again, you can make that into minutes. And then, so then it gives it to you, then you'll find, if you press enter, it's 166.08. Okay, so you could plug it in with degrees and minutes into your calculator, and that's what you have to do to solve for A and C if you don't already convert it. So it's kind of up to you as to how to do that. So let's just do sine. If I want to find A, you do sine of A times B over sine of B. Now I converted it already to decimals right here, right? So I could use that as well because the answer is going to be in decimals anyway. But you could plug in 5 degrees and 40 minutes, sine of 5 degrees and 40 minutes. And then times 4.8 over sine of 8 degrees and 15 minutes. You could type it into your calculator, or you can just do it in decimals like I did. So it's up to you as to how you want to do it, but that is how you do these problems with the degrees and minutes as opposed to just in decimals. Okay, so I hope this helps you out.